As we look at rational functions, we need to investigate where there are asymptotes and holes. How do you find those? Well, first of all, we start with a rational function, and you want to factor the numerator and denominator if you can. So I believe we could factor this. Check your signs, and yes, that is indeed factored. And we want to reduce this to lowest terms if you can, and notice that they have a common factor of 2x minus 1. That's where you can have a hole in the graph. If you have a common factor, there is going to be a hole, not an asymptote, which we would represent by a dashed line, but this is actually a very small hole in the graph. So we want to set that common factor equal to 0 and solve for x. Now that is where the hole will be. Now we need to know what the y value of that hole. And so we have to substitute this x value into the reduced function. And so our reduced function is 2x plus 1 over x plus 3. And I want to evaluate that at 1/2. So let's see, that's going to be 2 over 3.5, and 3.5 is 7/2. So that would be 2 times 2 over 7, which would be 4/7. So our hole is going to exist on the graph when x is 1/2 and y is 4/7. On a graphing calculator, you would never find that hole because it's going to only be 1 pixel big. Unless you knew exactly where to zoom in, you would never see it. So that's why we've got to have the algebra. Now, how do we find vertical asymptotes? These exist where the reduced function is undefined. So as I go back to my reduced function, now where is that undefined? Well, of course, that's when the denominator equals to 0. So we're going to set that denominator equal to 0 and solve for x. And so we would have a vertical asymptote, which I'm going to abbreviate as V8, and we would draw that on the graph as a vertical line, something like that. Now, how do we find horizontal asymptotes? Well, those do not always exist. They only exist if the degree of the numerator is less than or equal to the degree of the denominator. Now remember, the degree just means the highest exponent. And so if we go back to our reduced equation that we just had, which was 2x plus 1 over x plus 3, what would be the degree of the numerator and the denominator? Well, the degree on that x is 1, the degree on that x is 1, and so those degrees would be equal. Well, if the degree of the numerator is equal to the degree of the denominator, the horizontal asymptote is, and this is very important, y equals, because it is a horizontal line, it's going to be the ratio of the leading coefficient. Now the leading coefficient means the number in front of the x with the highest power, so that would be 2, divided by the leading coefficient of the denominator, and again that would be the number in front of the x with the largest degree, which would be 1. And so our horizontal asymptote is y is equal to 2, and again we would represent that as a dashed horizontal line. Now I want to go back and make sure you've read this, that if the degree of the numerator is less than the degree of the denominator, you don't have to do any work. The horizontal asymptote is always going to be y is equal to 0. And of course you can just write that down. And so the other option is when is the degree of the numerator greater than the degree of the denominator. That's when you have an oblique asymptote. And we're going to find those oblique asymptotes using long division of polynomials. So of course we need to review that. So let's take a look at a different function. We're not going to go through all the steps. We could, but let's just find the oblique asymptote. Notice the degree of the numerator is 2 and the degree of the denominator is 1, and so the top is bigger than the bottom, and we're going to find the oblique asymptote by using long division. So this is our divisor. Then we're going to divide into x squared minus 1. You might remember you need a placeholder, so I'm going to say 0x minus 1. How do you do long division? You look at those first two and divide them and say, that goes in there x times, and then we multiply those. We put it right underneath here. Then we subtract, so we're going to draw our line, change our signs. And so then we would have 0 minus 2x, and we'd bring down the next term. Then we repeat the process. We look at those first two and divide, and again we're going to multiply that out in front, so we'd have negative 2x minus 4. Going to subtract, so again that cancels, and then we have a remainder of 3. We're not concerned about the remainder. We want the quotient, which is this part without the remainder. Now our answer, if you just put x minus 2, that's not right. We're looking for an asymptote, which is an equation of a line. It could be not a line, but in our case it's going to be a line. We need to know that this is going to be y equals to x minus 2. How do you graph that? Well, you need to know that that's a line where the slope is 1 and b is negative 2. And so you'd come down here at negative 2 over 1 and up 1, and again you would represent that by a dashed line. If you need other examples, I recommend that you Google long division of polynomials, and you'll have lots of YouTube videos wanting to help you out.